Have you ever imagined what a top predator was like 150 million years ago? Let me introduce you to the Allosaurus, a carnivorous dinosaur from the Late Jurassic. With unique concave vertebrae and a robust structure, it was first described by paleontologist Othniel Charles Marsh in 1877. Measuring an average of 8.5 meters in length, the Allosaurus was a skilled hunter, using its powerful legs to run and its small three-fingered hands to grasp prey. It dominated ancient ecosystems in North America and Portugal, hunting large herbivores like stegosaurs and sauropods. Let's explore the world of the Allosaurus and uncover the secrets of this Jurassic giant. The Allosaurus is an extinct genus of large carnivorous theropod dinosaurs that lived about 155 to 145 million years ago during the Late Jurassic. The name Allosaurus, meaning different lizard, refers to its unique concave vertebrae, and it was first described by paleontologist Othniel Charles Marsh in 1877. The best-known species, Allosaurus fragilis, averaged about 8.5 meters in length, with some specimens reaching 9 meters and 70 centimeters. Despite its powerful legs, its three-fingered hands were small, and its body was balanced by a long tail. Allosaurus is classified as an allosaurid within the clade Carnosauria and includes at least 3 valid species, with Allosaurus fragilis being the most recognized. Its fossils have been found primarily in the Morrison Formation of North America and also in the Lourinhã Formation in Portugal. For much of the 20th century, it was known as Antrodemus, but later research reinstated the name Allosaurus. This dinosaur was at the top of the food chain in the Morrison Formation, likely hunting large herbivorous dinosaurs such as ornithopods, stegosaurs, and sauropods. There is debate over whether the Allosaurus hunted in groups or was a solitary predator that gathered to feed on the same carcasses. The discovery of Allosaurus was complex due to the multiplicity of names created during the bone wars of the 19th century. The first fossil was described in 1869 and attributed to the European genus Poecilopluron before receiving its own name, Antrodemus. Later, Marsh identified the fossils as Allosaurus fragilis. The competition between Marsh and Edward Drinker Cope resulted in several other names, such as Creosaurus and Labrasaurus. Nomenclature issues persisted until Charles W. Gilmore, in 1920, suggested using Antrodemus as the primary name due to the priority of the older name. However, in later studies, James Henry Madsen reinstated the name Allosaurus, highlighting the diagnostic inadequacies of the Antrodemus material. The name Antrodemus is still used informally to distinguish between skulls restored by different researchers. The Cleveland Lloyd dinosaur quarry, located in Emery County, Utah, had its first work done in 1927, with a description made by William L. Stokes in 1945. However, major excavations began only in 1960, led by James Henry Madsen, and with the collaboration of nearly 40 institutions. Between 1960 and 1965, thousands of bones were recovered, especially of the theropod Allosaurus fragilis, which dominate the site. It is estimated that the remains of at least 46 individuals of Allosaurus fragilis were found, within a minimum of 73 dinosaurs. The quarry has sparked scientific interest due to its still not fully explained formation, with theories ranging from mud traps to drought around a waterhole or lake formation. The skeletal remains vary in size, from less than 1 meter to 12 meters in length, and are disarticulated, facilitating detailed study of the bones. This quarry and another in Utah contributed to the designation of Allosaurus as the state fossil of Utah in 1988. Since Madsen's monograph, there have been significant advances in the study of the biology and ecology of Allosaurus, including aspects such as growth, hunting behavior, cranial structure, and group living. In 1991, Big Al, MOR 693, a 95% complete and partially articulated Allosaurus specimen, about 8 meters long, was found in Shell, Wyoming. In 1996, Big Al 2, the most well-preserved skeleton to date, was discovered by the same team, both classified as Allosaurus jimitsini. The original Big Al had 19 broken or infected bones, which may have contributed to its death. 6 species of Allosaurus have been named: Allosaurus amplus, Allosaurus atrox, Allosaurus europaeus, Allosaurus fragilis, Allosaurus gimitsini, and Allosaurus lucasi. Of these, only Allosaurus fragilis, Allosaurus europaeus, and Allosaurus gimitsini are considered valid. Allosaurus fragilis, named by Marsh in 1877, is the most common species, with remains of at least 60 individuals found in the United States. Allosaurus gimitsini was identified based on anatomical differences, such as a jugal with a straight lower edge. Allosaurus europaeus was found in Portugal, but may be a variation of Allosaurus fragilis. The Allosaurus in Portugal was first reported in 1999, based on a partial skeleton, MHNUL00, attributed to Allosaurus fragilis. However, a partial skull and neck, ML415, led to the naming of the species Allosaurus europaeus. Although it shows some cranial differences, new material may confirm it as Allosaurus fragilis. The issue of species and potential synonyms of Allosaurus is complex, especially since the type specimen of Allosaurus fragilis, YPM 1930, is very fragmentary. It consists of a few incomplete vertebrae, limb fragments, rib fragments, and a single tooth. Because of this, some scientists have considered the type specimen to be dubious, suggesting that the genus Allosaurus or the species Allosaurus fragilis could be a nomen dubium, dubious name, based on a very incomplete specimen. To resolve this issue, Gregory S. Paul and Kenneth Carpenter submitted a petition in 2010 to the ICZN to officially transfer the name Allosaurus fragilis to a more complete specimen, USNM 4734, as a neotype. This decision was ratified by the ICZN on December 29, 2023. Creosaurus, Epantarius, and Labrasaurus are considered junior synonyms of Allosaurus. Most of the species seen as synonyms of Allosaurus fragilis, or incorrectly attributed to the genus, are obscure and based on fragmentary remains. Labrasaurus ferox, named in 1884 by Marsh, stands out as an exception. It was based on a partial lower jaw with an unusual shape. Later research suggested that the unusual shape was due to injuries in the living animal and reconstruction with plaster. It is currently considered an example of Allosaurus fragilis. Gregory S. Paul proposed in 1988 that Allosaurus fragilis had high horns and a slender build compared to Allosaurus atrox, a second postulated species. Allosaurus atrox was originally named by Marsh in 1878 as the type species of Creosaurus. The 2000 thesis on Allosauridae refuted the supposed differences between USNM 4734 and the specimens referred to as Allosaurus atrox. Other names attributed to Allosaurus include Allosaurus agilis, Allosaurus ferox, Labrasaurus fragilis, and Allosaurus whitei, which are typographical errors or nomina nuda. Matsenius and Wyoming raptor were considered synonyms of Allosaurus. Several species and fossils initially attributed to Allosaurus do not belong to the genus. Allosaurus medius was named by Marsh in 1888, but was later removed to Dryosaurus grandis, except for a tooth. Allosaurus valens is a new combination for Antrodemus valens, which may belong to Allosaurus fragilis. Allosaurus lucaris and Allosaurus sibiricus are considered nomina dubia. Allosaurus mariani was a new combination for Megalosaurus mariani, but it is now included in Ceratosaurus. Apatodon myrus was listed as a synonym of Allosaurus fragilis, but it is indeterminate beyond Dinosauria. Allosaurus amplexus was designated by Gregory S. Paul for remains of a large Morrison allosaurid, including Saurophagus maximus. After Paul's work, it was accepted as a synonym of Allosaurus fragilis. However, a 2010 study suggests that Epantarius is, at the very least, a separate species. In 1995, Chure created the taxon Saurophaganax maximus for remains of large allosaurids from the Morrison Formation in Oklahoma, previously known as Saurophagus. Due to the name already being in use, Chure proposed the change. In 1998, David K. Smith suggested that these remains were not sufficiently distinct from Allosaurus to constitute a separate genus, proposing the name Allosaurus maximus. However, this reclassification was rejected in a review of basal tetanurans. Previously attributed remains to the synonyms Creosaurus and Labrasaurus have also been reviewed. Creosaurus potens, named by Lull in 1911 from a vertebra of the Lower Cretaceous of Maryland, is now considered a dubious theropod. Labrasaurus statui, described in 1920 by Genus based on teeth found in Tanzania, was listed as a species of Allosaurus, but is now seen as a dubious ceratosaur. L. sulcatus, named by Marsh in 1896, is also classified as a dubious ceratosaur. Allosaurus tendegurensis, named in 1925 by Janensch, is based on a partial tibia found in the Tendaguru Formation in Tanzania. Although it was considered a valid species of Allosaurus, recent studies have classified it as indeterminate beyond tetanuri, possibly being a carcharodontosaurid or megalosaurid. It was a large theropod, possibly about 10 meters long and 2.5 tons in weight. In 2003, Kurzanoff and colleagues designated 6 teeth from Siberia as Allosaurus sp, but these were later reclassified as an indeterminate theropod. Remains of Allosaurus in China were identified as Torvosaurus in 2012. An astragalus found in Australia, initially attributed to Allosaurus, was contested but later identified as possibly belonging to something similar to Australovenator. Allosaurus was a typical large theropod with a huge skull, short neck, long tail, and reduced forelimbs. Allosaurus fragilis, the best-known species, averaged 8.5 meters in length and 1.5 metric tons in mass. The largest definitive specimen, AMNH 680, was estimated to be 9.7 meters long, weighing between 2.3 and 2.7 metric tons. In 1976, James H. Madsen mentioned a maximum length of 12 to 13 meters. Weight estimates vary, but John Foster suggests that a metric ton is reasonable for large adult Allosaurus fragilis, while 700 kilograms is a closer estimate for medium-sized individuals. Using the subadult specimen Big Al, researchers estimated its weight at about 1.5 metric tons. Allosaurus europaeus was measured at up to 7 meters in length and 1 metric ton in body mass. Allosaurus jimitsini is a species known for its skeletal reconstruction, but many specimens attributed to it may belong to other genera. The sauropods, OMNH 1708, a closely related genus, may have reached about 10.5 meters in length and is sometimes included as Allosaurus maximus. However, recent studies suggest that Sauropods is a separate genus. Another specimen possibly belonging to Allosaurus, formerly attributed to Epanterius, AMNH 5767, may have measured 12 meters in length. A recent discovery is a partial skeleton found in the Peterson quarry in New Mexico, which may be another individual of Sauropods. David K. Smith, analyzing Allosaurus fossils by quarry, found that specimens from the Cleveland Lloyd dinosaur quarry in Utah were generally smaller than those from Como Bluff in Wyoming or Dry Mesa quarry, Brigham Young University in Colorado. However, bone shapes did not vary significantly among these locations. A subsequent study by Smith, including specimens from Garden Park, Colorado, and Dinosaur National Monument, Utah, found no justification for multiple species based on skeletal variation. Skull variation was gradual and more common, suggesting individual variation. Later works found no consistent size-related differences, although material from Dry Mesa showed clustering based on the astragalus. Kenneth Carpenter, studying skull elements from the Cleveland Lloyd quarry, observed wide individual variation, questioning species distinctions based on features like horn shape, and the proposed differentiation of Allosaurus jimitsini based on jugal shape. A study by Motani et al., published in 2020, suggests that Allosaurus was sexually dimorphic, with differences in femur head width relative to length. The skull and teeth of Allosaurus were proportionate for a theropod of its size. Paleontologist Gregory S. Paul estimates a length of 845 millimeters for the skull of an individual that would have been about 7 meters and 90 centimeters long. Each premaxilla contained 5 D-shaped teeth, and each maxilla had between 14 and 17 teeth, with no exact correspondence between tooth number and bone size. The dentary had between 14 and 17 teeth, averaging 16. The teeth were shorter, narrower, and more curved towards the back of the skull, with serrated edges, and were frequently replaced, making them common fossils. The skull was light, robust, with dozens of sharp, serrated teeth. Allosaurus had a pair of horns above the eyes composed of extensions of the lacrimal bones, varying in shape and size, with lower ridges along the nasal bones leading to the horns. Covered in keratin, the horns could have functions such as eye protection, display, and combat. There was a crest on the top of the skull for muscle attachment, also seen in tyrannosaurids. The lacrimal bones had depressions that might have housed glands such as salt glands. The maxillae had more developed sinuses than in basal theropods, possibly related to the sense of smell, containing structures similar to Jacobson's organs. The roof of the brain case was thin, potentially for thermoregulation. The skull and jaws had joints allowing movement. In the jaws, the bones were loosely articulated, permitting flexion and increased mouth opening. The brain case and frontals might have also had articulations. Allosaurus had 9 neck vertebrae, 14 in the back, and 5 in the sacrum supporting the hips. The number of tail vertebrae varied with size. James Madsen estimated around 50, while Gregory S. Paul suggested 45 or fewer. Hollow spaces in the neck and back vertebrae, also found in birds, indicated air sacs used in respiration. The ribcage was broad, especially compared to theropods like Ceratosaurus. Allosaurus had gastralia, but they were rarely found and possibly poorly ossified. In one case, a gastralium showed injury. A furcula was present but only recognized in 1996, previously confused with gastralia. The ilium was massive, and the pubis had a prominent foot used for muscle attachment or ground support. Madsen noted that in about half the Cleveland Lloyd individuals, regardless of size, the pubes were unfused, suggesting a sexual characteristic to facilitate egg-laying, a proposal that received little further attention. The forelimbs of Allosaurus were short compared to the hind limbs, about 35% the length of the hind limbs in adults, and had 3 fingers per hand, with large, curved, and pointed claws. The arms were powerful, and the forearm was shorter than the upper arm, ulna-humerus ratio of 1 to 1.2. The wrist had a semi-lunate carpal, found in more derived theropods. Of the 3 fingers, the innermost was larger and diverged from the others. The phalangeal formula is 23400, indicating that the innermost finger has 2 bones, the next 3 and the third 4. The legs were not as long as in tyrannosaurids, and the toe claws were more hoof-like than claw-like. Each foot had 3 weight-bearing toes and an inner claw, suggested by Madsen to grasp juveniles. There was also a remnant of a 5th metatarsal, possibly used as a lever between the Achilles tendon and foot. Skin impressions of Allosaurus have been described. One impression from a juvenile measures 30 square centimeters associated with the pectoral region, showing small scales of 1 to 3 millimeters. Impressions of Big Al2, associated with the base of the tail, measure 20 by 20 centimeters, with scales up to 2 centimeters. Noted that these scales are similar to sauropods, the impression might not be of Allosaurus. Another fossil shows scales on the jaw, with 1 to 2 millimeters in diameter, and impressions of the neck, with broad plates. A skull skin impression was reported but not described. Allosaurus was an allosaurid part of Carnosauria. The family name Allosauridae was created by Othniel Charles Marsh in 1878, but ignored until the 1970s in favor of Megalosauridae, which became a wastebasket taxon. With the use of Antrodemus for Allosaurus, it is important to consider publications prior to James Madsen's 1976 monograph. Major publications using Megalosauridae instead of Allosauridae include Gilmore, 1920, von Huyn, 1926, Romer, 1956 and 1966, Steele, 1970, and Walker, 1964. Following the publication of Madsen's influential monograph, the term Allosauridae became the preferred family designation, but it was not clearly defined. Semi-technical works used Allosauridae to classify various large theropods, generally larger and more well-known than megalosaurids. Theropods such as Indosaurus, Piatnitskysaurus, Pivotosaurus, Yangchuanosaurus, Acrocanthosaurus, Chilentysaurus, Compsogsuchus, Stoxosaurus, and Szechuanosaurus were considered relatives of Allosaurus. The abundance of Allosaurus fossils, representing almost all ages of individuals, allows scientists to study their growth and longevity. There are even suggestions that eggs found in Colorado could belong to Allosaurus. Histological analyses of limb bones indicate that bone growth ceases between 22 and 28 years, similar to other large theropods like Tyrannosaurus. Maximum growth occurs around 15 years, with an estimated rate of 150 kilograms per year. The presence of medullary bone tissue was reported in at least one Allosaurus specimen, a shin bone from the Cleveland Lloyd quarry. This tissue, found today only in female birds laying eggs, indicates that Allosaurus had reached reproductive age. However, some studies question the identification of medullary bone in dinosaurs, suggesting it could result from bone pathology. The discovery of a juvenile specimen reveals that the legs were relatively longer in the young, with longer lower segments relative to the thigh. This suggests that young Allosaurus were faster and had different hunting strategies than adults, possibly hunting small prey and, as they grew, becoming ambush predators of large prey. The thigh bone thickened with growth, indicating that juveniles endured less predictable stresses compared to adults. Most paleontologists consider Allosaurus an active predator of large animals. There is evidence of attacks on stegosaurs and sauropods, such as Allosaurus tooth marks found with sauropod bones. However, due to its size and characteristics, Allosaurus likely did not hunt fully grown sauropods without group assistance, preferring to hunt the young. Robert T. Bakker compared Allosaurus to saber-toothed mammalian carnivores, suggesting that it used a neck and jaw attack technique to weaken larger prey. Biomechanical analyses indicate that the skull of Allosaurus was strong, but had a relatively small bite force. This suggests it could use its skull like a knife, slicing flesh without fracturing bones. Other theories propose that Allosaurus could bite the flesh of living prey to feed, without killing them, or hunt ornithopods using a technique similar to modern big cats, grabbing the prey with its forelimbs and biting the throat. Studies suggest that Allosaurus could open its mouth at a 92-degree angle, more than Tyrannosaurus and Erlikosaurus, allowing for a wide gape during attacks. Sauropod carcasses were also important for large theropods in the Morrison Formation. Allosaurus would have fed on sauropod carcasses at all stages of decomposition, unaffected by pathogens from advanced decay. In summary, Allosaurus was a theropod dinosaur with hunting strategies adapted to its physical characteristics, hunting large and small prey with various techniques and scavenging carcasses when necessary. Its growth, reproduction, and feeding capabilities make it one of the most well-studied and fascinating predators of the Jurassic period. It has been argued that individuals like Big Al and Big Al II could have survived as scavengers of large sauropods due to their injuries. Recent paleopathological studies indicate a correlation between fractures in allosaurids and a lifestyle involving greater chances of recovery, even with severe injuries. The difference between allosaurids and tyrannosaurs regarding injuries may reflect different strategies for resource access in environments like the Morrison Formation, which has been interpreted as an arid environment, though this view has been criticized in more recent studies. Since the 1970s, it has been speculated that Allosaurus hunted in groups. Robert T. Bakker suggested that these dinosaurs might care for their young and defend their resources. However, evidence of gregarious behavior among theropods is limited, and many interactions may have been aggressive. The accumulation of Allosaurus remains in one location may result from cannibalism or competition for food rather than cooperative hunting. The brain of Allosaurus, based on CT scans, is more similar to crocodiles than to modern birds. The vestibular apparatus indicates that the skull was held nearly horizontal, and the structure of the inner ear suggests an ability to hear lower frequencies. Its olfactory bulbs were large, suitable for detecting odors. Studies have revealed that Allosaurus had a significant number of stress fractures and avulsion injuries. These injuries suggest a diet based on active predation. Specimens like USNM 4734 and MOR 693 exhibited various pathologies, including healed fractures and bite marks, some of which may have been caused by cannibalism. Allosaurus was the dominant theropod in the Morrison Formation, representing a large portion of theropod specimens. The Morrison Formation is interpreted as a semi-arid environment with varied vegetation and diverse fauna. Allosaurus coexisted with other large theropods like Ceratosaurus and Torvosaurus, each occupying distinct ecological niches. There is evidence that Allosaurus may have been cannibalized by other theropods, and that competition for resources was intense. This summary covers key points, including aspects of survival and behavior, brain structure and senses, paleopathology, and the paleoecology of Allosaurus. Allosaurus is one of the most fascinating predators of the Late Jurassic, and its attack technique remains one of the greatest mysteries of paleontology. Biomechanical analyses indicate that, despite its strong skull, its bite force was relatively small. This suggests it used its skull like a knife, slicing flesh from its prey without fracturing bones. Additionally, other theories propose that Allosaurus could bite the flesh of living prey to feed without killing them, or hunt ornithopods using a technique similar to modern big cats, grabbing the prey with its forelimbs and biting the throat. These theories offer a fascinating glimpse into how Allosaurus might have lived and hunted. Stay tuned for more incredible discoveries about the world of dinosaurs. Until next time.